In the cold emptiness between stars, something has been drifting toward us for longer than Earth has existed. 7 billion years of silence, carrying secrets older than our sun. Older than our planet, older than life itself. Astronomers call it the third interstellar visitor. But that bland scientific label doesn't even come close to describing what it truly is. This is not a comet like the ones we've seen before. This object breaks the rules of physics. It ejects chemicals that should not exist. It travels at speeds no natural object can sustain. And when it reaches its closest point to the Sun on October 29, 2025, we will lose sight of it entirely. For weeks, the most dangerous phase of its journey will unfold in total darkness. Some call it a time capsule. Others call it a threat, and a few whisper that it might not be natural at all. This is the story of the most mysterious object humanity has ever encountered. And if the worst-case scenarios come true, our solar system may never be the same again. Prepare yourselves. The countdown has already begun. Please subscribe, like, and comment. Thank you so very much. I try and deliver the very best content that I can, for your viewing pleasure. It began on July 1st, 2025. In the Chilean desert, the Atlas Survey telescope scanned the sky, looking for killer asteroids. Atlas was designed as humanity's early warning system, photographing the entire visible sky every 2 nights to catch anything headed our way. But what it found that night was not an asteroid. At first, the object appeared faint, just a smudge of light drifting against the background stars, but its movement was off. When astronomers calculated its path, they realized it wasn't orbiting the Sun like a normal comet. It was following a hyperbolic trajectory, a path that enters the solar system once and then escapes forever. That meant it came from interstellar space. We had seen this only twice before, Oumuamua in 2017 and Borisov in 2019. But this one was different. This one was older, much older, by analyzing its trajectory and chemical hints. Astronomers traced its origins to the galactic thick disk region of the Milky Way populated by the oldest stars in existence. Stars that were ancient before our Sun was even born. That means this object formed billions of years before Earth. Think about that for a moment. While our solar system was still just a swirling disk of dust and gas, this frozen wanderer was already complete. It has survived countless cosmic catastrophes, supernovae, radiation storms, collisions, and still it arrived here, now, at this exact point in human history. At first, scientists were thrilled. This was a time capsule from the dawn of the galaxy. But the more they studied it, the more uneasy they became, because very quickly, it started breaking the rules. Every astronomy textbook tells the same story. Comet tails always point away from the Sun. Solar radiation and the solar wind push dust and gas outward, forming those familiar glowing trails. But not this one. This interstellar visitor developed what scientists call an anti-tail. Instead of streaming away from the Sun, dust and debris projected forward, pointing in the wrong direction, directly toward the Sun. At first, astronomers thought it was an instrument error. But repeated observations confirmed it. This wasn't a glitch. It was real. How is that possible? Normal comet tails are made of microscopic dust particles smaller than a human hair. They're so light that solar radiation pressure easily pushes them outward. But this visitor ejects much larger particles, big enough to resist solar forces. They kept their forward momentum, forming a strange shield of debris ahead of the object. The implications are staggering. It's as if the comet is building a buffer zone in front of itself, a protective shield thousands of miles wide. Natural processes should tear such a structure apart, but somehow it holds, And the timing is suspicious. The anti-tail became visible just as the object entered the asteroid belt, the most dangerous region of our solar system, filled with trillions of rocks capable of shattering it. Some researchers began whispering the unthinkable. What if this wasn't natural at all? What if the anti-tail was technology, a navigation system designed to detect obstacles and protect an interstellar craft as it crosses hazardous star systems? The irony was impossible to ignore. The Atlas system was created to save us from extinction-level asteroid impacts. And yet, the very same system had discovered something potentially far more dangerous, an ancient interstellar visitor with behaviors that defy physics. In 20 years of sky surveys, astronomers had confirmed only to other interstellar visitors. This third one was instantly the strangest of them all. Its speed alone was shocking. Most comets approach the Sun at 204,000 miles per hour. This object cruises at 137,000 miles per hour over 60 kilometers per second. At that velocity, it could cross the United States in under 2 minutes. Its trajectory confirmed what its speed implied. This wasn't a returning comet. This was a once-in-history flyby. It would never orbit back again if we failed to study it now. The opportunity would be gone forever. But the more telescopes focused on it, the stranger it became. The object wasn't just fast, it was active. Its brightness fluctuated unpredictably, as if internal processes were powering it. Some even suggested it was maintaining itself, resisting the damage that 7 billion years of interstellar travel should have inflicted. One question loomed larger with every new discovery. If it's not just a comet, then what is it? When the James Webb Space Telescope aimed its powerful instruments at the visitor, scientists expected familiar results. Most comets are made primarily of water ice, with traces of carbon monoxide and dust. But this was different. Its atmosphere was dominated by carbon dioxide. Water, the usual star of the show, was only a minor trace. In fact, the ratio of CO to HEO was unlike anything ever observed in any comet, interstellar or otherwise. Worse, the gases it emitted were toxic: cyanide, carbonyl sulfide, carbon monoxide, atomic nickel vapor. The cocktail was so lethal that a human would die instantly if exposed to even a trace of it. And then came the strangest part. Atomic nickel requires incredibly high temperatures to exist in gas form, far higher than the cold environment of deep space. Yet this object emitted it continuously. That suggested an internal heating mechanism operating independently of the Sun, the visitor's comet's surrounding atmosphere was enormous, over 200,000 miles across, larger than the distance from Earth to the Moon. As it grew, it became not just a curiosity, but a hazard. Any spacecraft crossing its path would be swallowed by a toxic, radioactive cloud. This wasn't just a comet. This was something entirely new. And the most dangerous part of its journey was still ahead, on October 29th. The visitor will reach perihelion, its closest point to the Sun. That's when it will be heated more violently than at any point in its 7 billion-year existence. For comets, perihelion is always a moment of crisis. Outgassing surges, surfaces explode, fragments break away. Many don't survive. But for this interstellar visitor, the stakes are higher than ever. Its exotic chemistry and weakened structure could trigger catastrophic disintegration. And just as this happens, Earth will go blind. Because of its position in the sky, the object will pass directly behind the Sun from our perspective for weeks. It will be invisible to all Earth-based telescopes. Even most space-based instruments will be unable to observe it without risking permanent damage from the Sun's glare. That means the most dangerous, most unpredictable part of its journey will unfold in total secrecy. By the time it reemerges in December, it could be intact, shattered into hundreds of deadly fragments, or gone entirely. We won't know until it's too late. Even if the visitor survives its violent encounter with the sun, its journey isn't over. In fact, the next stage may be even more dangerous. Its hyperbolic trajectory carries it directly through Mars's orbital path in early November. For now, the calculated odds of collision remain low, but the uncertainty is unnerving. A fragment just a few hundred meters wide, traveling at 137,000 miles per hour, would strike with the force of billions of nuclear bombs. Entire regions of Mars would be vaporized. The shockwave could destabilize polar ice caps, trigger global quakes, and eject dust high enough to create a temporary atmosphere. The red planet's fragile ecosystem, along with every robotic mission we've deployed there, would be in jeopardy. And even if Mars is spared, the visitor must then navigate the asteroid belt, a region filled with over 1 trillion rocks larger than 65 feet across. Space might look empty, but at this scale, collision odds rise dramatically. At these velocities, even a modest impact would vaporize both objects in an instant. Worse, such a collision could trigger a cascading chain reaction, fragments hitting other asteroids, producing secondary debris clouds that ripple across the belt for decades. Imagine a cosmic minefield, seeded not just by random rock, but by fragments of an exotic, toxic interstellar body. That is the nightmare scenario astronomers now calculate in their simulations. The more anomalies appeared, the harder it became to ignore the possibility. What if this visitor isn't natural at all? Harvard astrophysicist Avi Loeb, the same researcher who argued Oumuamua might have been artificial, has once again stepped forward. His reasoning: too many coincidences line up. The anti-tale: natural comets don't project massive particles forward like a shield. This looks like a navigation system, electromagnetic silence, despite violent outgassing. The visitor emits no detectable radio waves for a natural comet. That's bizarre for stealth technology. Perfect sense. Preservation: after 7 billion years in interstellar space, a natural object should be heavily degraded. Yet this one seems remarkably intact. Energy use: the forward particle shield requires continuous power far beyond normal solar heating. Loeb and others propose a radical idea. This could be an ancient probe, sent across the galaxy to survey young star systems. A mission of reconnaissance, not contact. That theory dovetails with the chilling dark forest hypothesis, the idea that advanced civilizations hide in silence, watching others, ready to strike if they see a potential threat. If that's true, then this object may not just be a relic of cosmic dawn. It may be evidence that we are not alone, and never were. The visitor's trajectory itself raises eyebrows. It entered during humanity's first century of radio communication and space exploration, the exact moment when our presence became detectable. Coincidence? Maybe. Or maybe this was no random flyby. The implications are terrifying. If it's reconnaissance, then someone, somewhere, now knows exactly what lives in this solar system, and they may have known for a far longer than we. Realize, whatever it truly is, natural relic or artificial probe, one fact is certain: we have only a few months left to study it after its pre-alien passage and Mars encounter. The visitor will slingshot past the sun and accelerate back into the void. By late 2026, it will have crossed Jupiter's orbit. Soon after, it will leave the solar system forever. At its current velocity, it will travel into the outer galaxy, never to return. That means humanity gets exactly one chance to measure its chemistry, one chance to track its fragments, one chance to ask whether we are witnessing the oldest surviving natural object ever detected, or The stealthy technology of a civilization billions of years older than our own. The data already gathered will take decades to analyze. But many questions will never be answered. What internal process powers its strange emissions? Why does its chemistry look like nothing else in the universe? And if it really is technology, who built it, and why? When it disappears into the dark between stars, it will leave more mysteries than answers. But it will also leave us with something else, a reminder of our cosmic vulnerability. Because this encounter has taught us a hard truth: our planetary defense systems, the telescopes, radars, and networks designed to spot asteroids are useless against interstellar visitors. They travel too fast, they behave too strangely, and sometimes they vanish behind the sun when we most need to see them. We have learned that our solar system is not isolated. We live in a galaxy where ancient wanderers arrive without warning, carrying secrets we cannot predict or defend against. Some may be natural, some may not be, but all remind us of the same unsettling fact: we are not alone in the universe, and we are not safe. So when October 29th arrives, and this 7 billion-year-old traveler vanishes behind the sun, ask yourself, what will emerge on the other side? A shattered relic of cosmic dawn, or proof that intelligence older than Earth has already visited? US, whatever the answer, one thing is certain: humanity's story has just entered a new chapter. Stay watching the skies.